Welcome back. It's time to start the new chapter. And as you can see here, this is a chapter that deals with security. Now, if you take a look in this page, we explain why this topic is going to be a critical topic for at least some of you guys. Trust me, having lived 15 years in Arlington, Virginia, next to Washington, D.C., I know that a lot of customers have been asking for encryption for many years. Obviously, they want to protect their data. And in this chapter, we're going to talk about two different things. On one hand, we are going to talk about data at rest encryption. Data at rest encryption is not a new feature. We've had that since vSAN 6.6, meaning since vSphere 6.5 Update 1. I'm going to do one demo, and in that demo, I am going to show you how to configure data in transit encryption. Data in transit encryption is brand new in 7.0 Update 1. Now, as I go through this lecture, you're going to hear me use different acronyms. I'm going to explain to you every single one of the acronyms, what they are, what they stand for, and what they do. So if you take a look, in this page, we show you that for the first time ever, you have two choices when it comes to encryption. On one hand, you can enable data at rest encryption. We've had that before. This has been around since vSAN 6.6. If you want to use data at rest encryption, you need to basically get your hands on a KMS server. VMware does not provide a KMS server, but you can get one from different vendors, such as Dell, EMC, HiTrust, IBM, and so on. But when you look at this illustration, at the bottom, you have the new choice, which is data in transit encryption. Please understand that data in transit encryption does not require a KMS server. This allows me to encrypt the data as it flows through the vSAN network. And what this does is it allows me to protect myself against a man-in-the-middle type of attack. Now, when it comes to design considerations, the most important thing here is not to put your KMS server in your vSAN data store. So if you take a look, that's what we mentioned in bullet number 1. Bullet number 2 mentions that encryption operations are offloaded to the modern CPUs, so it doesn't really have a huge impact when it comes to performance. Some people may notice a 5% difference when it comes to CPU activity because of encryption. This is not for stretch clusters or 2-node clusters. Here we're talking about, again, encryption at the data store level. And if you take a look, if you enable data at rest encryption, if you have a core dump, the core dump automatically will be encrypted because your server will be in crypto-safe mode. If you take a look at the bottom of the page, they tell you that you don't have to enable both features. You don't have to enable either one, I guess, but you could enable data at rest encryption without data in transit encryption or vice versa. And if you take a look, on this page we talk about roles and permissions. Now, ever since vSphere 6.5, we have had a role called No Cryptography Administrator. So if I work with somebody else and I'm in charge, if I want to be the only one that in a nutshell messes around with encryption, I am going to log in as administrator at vSphere.local. But if I'm working with somebody else and I don't trust that person when it comes to touching my KMS related configuration, I will create an account for him and I will assign him to the role called No Cryptography Administrator. When you take a look, I've already mentioned that you need to get a KMS server if you want to enable data at rest encryption. If you look at the VMware hardware compatibility guide, you will notice that there's a lot of different KMS servers that we support. They need to be running KMIP version 1.1. And if you take a look, the last time I looked at the list, you had a plethora of KMS servers. For example, you had some from IBM, Dell EMC, High Trust, and so on. The list continues to grow over time. I remember the very first two, if I'm not mistaken, were the ones from High Trust and Dell EMC. But recently, again, I've noticed that many more were added to that list. Now, what we try to tell you in this page is that you want to avoid the single point of failure. And your KMS server is going to be a critical component. So for obvious reasons, you want to cluster that KMS server. Be aware that you cannot mix and match two different KMS servers from different vendors. So again, both have to belong to the same vendor. And if you take a look, this starts by going to the vCenter server and actually going to the Configure tab. And when you go to the Configure tab, you select Key Providers. You will notice if you have a brand new vCenter that this section is empty. So step number one entails that you click on Add Standard Key Provider. You have to tell the vCenter who is the KMS server. You have to specify, for example, the port to use. And you need to establish trust. Here, you can see that they tell you that once you tell the vCenter who is the KMS server, notice the vCenter uses KMEP, which is the protocol, to communicate with the KMS server over SSL or TLS. And if you take a look, when you establish trust, what's going to happen is you're going to see a series of choices. The reason you see all these choices, once again, is because we support different KMS servers. Now, having said that, once you take care of this, the next thing you need to do is you need to go to your cluster. You need to select Configure. You need to go to Services under vSAN. And you need to say, I want to enable data at rest encryption. In this page, we mentioned three acronyms. Besides KMS, which I've already explained, they mention KEC, they mention DEC, and they mention HEC. KEC means Key Encryption Key. DEC is an acronym that stands for Data Encryption Key. And lastly, HEC is your Host Encryption Key. And in this page, we show you how all the components interact with each other. So this starts with the vCenter communicating with the KMS server. And as you can see, the vCenter server in step number one will request the KEC from the KMS server. Notice, the vCenter doesn't store the KEC, but it does store the KEC ID. At that point, the vCenter communicates with all the ESXi hosts in your cluster, and he sends the KEC ID to those hosts. In turn, the hosts will communicate, in this case, directly with the KMS server. And again, what they're going to be doing is they're going to be requesting the KEC from that KMS server. The reason here the hosts have to communicate directly with the KMS server is because if something's wrong with the vCenter and the vCenter happens to be in the vSAN data store, the hosts need to be able to communicate without a middleman. Notice, in turn, the host will create a DEC for each drive that they have. If you look at step number 5, notice it says each cache and capacity device is going to be encrypted using the DEC. And if you wonder, why do I need a HEC? The host encryption key is used to encrypt your core dumps should you end up with a purple screen of death. And if you take a look, here we're talking about what happens when you encrypt your existing cluster. If you have virtual machines, which we do, of course, when you enable data at rest encryption, the idea here is we're going to go through a DFC. Now, what do I mean by that? This is going to be a fairly long lab. Here in class, I would assume about 15 minutes. Because what's going to happen is every disk group is going to be taken apart temporarily so that the drives can be reformatted. You have the choice to move data around. And when you take a look, right, you can see it says when data at rest encryption is enabled on a new cluster, not what we have, but a new cluster, disks are going to be encrypted as soon as you create the disk scripts the first time. But here we already have VMs. And if you think about it, if we're going to be deleting disk scripts, the question is, what do we do with the data? So you have a couple of choices. One is not to take any chances and move all the data around. The other one entails that we enable a feature that is called allow reduce redundancy. And we're going to talk about that in a second. In this page, here to tell you that if you're going to be doing a DFC, the idea is you want to make sure that you do this when every host is up and running, none of the hosts are in maintenance mode, all the disks are healthy, all the disk scripts are healthy. And like I said, this could take a while. The more disks you have to format, the more hosts you have, the longer it will take. Remember, if you decide to move data around, that will generate a bunch of extra I/O. So you may not want to do this in the middle of the day. Maybe you want to do this off peak hours. Now here, you can see that after you tell the vCenter who is the KMS server, the idea is you get to choose whether you want to enable only data at rest encryption or both, that one and data in transit encryption. And then finally, you get the choice whether or not you want to wipe residual data. And as I mentioned earlier, you have the little checkbox for allow reduce redundancy. In this page, they explain to you that you don't necessarily have to use the option wipe residual data. That is nothing more than a choice. And in the lab, I believe that we didn't tell you to use that. So when you take a look, once you again enable data at rest encryption, you can enable that on its own. You can combine that with also the duplication and compression. Or again, you can combine and enable everything at once, meaning dedupe and compression, data at rest encryption, and data in transit encryption. Now, when you take a look, I've already mentioned what is wiping residual data. And here they give you an official explanation. Once again, this is not necessary. When it comes to allow reduce redundancy, remember, we're talking about evacuating the bare minimum to basically speed up the process. Having said that, remember, that means you will have absent components temporarily. And imagine, of course, the worst case scenario. What would happen if you have a failure while you're doing this upgrade? Now, when you take a look here, we are trying to explain to you what happens when you write data into your virtual disk. Now, let's take a look. When you look at the steps on the left side, first, they tell you that the I/O is going to be broken into chunks. At the point, a checksum is created. You can see then encryption is performed. Remember, data always goes to the cache tier first. And then from there, it moves to the capacity tier. So you can see it says encrypted data is written to the right buffer. Notice then, as we're ready to destage data to the capacity tier, decryption is performed. If you have also enabled dedupe and compression, the idea is simple. First, we perform dedupe and compression, then encryption, which of course means we're not sacrificing the space savings provided by dedupe and compression, because that takes place before encryption. And if you take a look, if you ever decide to grow the cluster, what's going to happen here is as you add a new host, when you look at the very top of this page, notice it says, when you add a host to your encrypted cluster, the new host will automatically receive the key encryption key and the host encryption key from the KMS server. So it's very easy to do that. Now, depending on your requirements, you may have to here and there perform a rekey operation. And you have two types of rekey operations. As you can see in this page, on one hand, you have a shallow rekey operation. On the other one, you have a deep rekey operation. Every time you do a deep rekey operation, that requires a brand new DFC. So again, that will take a while. On the other hand, in most cases, a shallow rekey operation will suffice. Here, you can see again, we're showing you exactly what happens when you decide to change your keys. You can see it says a shallow rekey operation replaces only the CAC. And again, the data does not require to be re-encrypted. That's why it doesn't take too long. But that is not the key, or not the case, I should say, if, for obvious reasons, you decide to do a deep rekey. You can see they tell you here that a deep rekey operation replaces both the CAC and the DAC. As mentioned, you may have certain needs, and among those needs, you may have to rotate your client certificates. So you can see again, all changes should be performed on the vCenter server. And if you take a look, after this chapter, you don't have one particular lab, you actually have two. In the first one, you point to your first KMS server and you enable data at rest encryption. In the second one, you're going to change from one KMS server to another. So that's why you see in this illustration, two KMS servers. These are the names of the KMS servers you're going to use. And if you take a look, out of the two of them, only one is going to be the default at once. But you can see again on the vSphere client, you have this choice to make the other one the default if that's what you want to do. But it's all about trust. Now, we mentioned earlier that if you have a purple screen of death, your core dump is going to be encrypted automatically. So what do you have to do? If you have an encrypted core dump and you want to send this to our support personnel, you need to provide a password just like we show you here. Because if you don't, the problem is we cannot analyze what is going on in your particular environment. So that takes care of the first part of this chapter. We're going to take a quick little break. And when we come back from the break, we're going to proceed and we're going to combine data in transit encryption with a quick little lab or a quick little demo, call it what you will. Thank you guys. I'll see you after the break.